Oh yes, you're welcome to Enock's videos, and today I want to talk about another research tool, that is the chi-squared test. It is used by researchers, and I guess you are a researcher, and I want you to look at my presentation and pick out something. Most of these tests we use formally, like in this case this is the chi-squared test that we are going to be using, and we are trying to break it down what each of these letters and symbols mean. The summation means sum. Let me try to highlight on it. This means sum, just like you can add up something. And then O means observed value, so in other words, what you get in an experiment. And then we have what we call the expected value. In other words, what would you expect to get out of the experiment? So we always use it to find out or to determine whether any difference in the observed results and the expected results is really significant or it is due to chance. It is very vital to understand this. Okay. So you need to know that this test allows us to compare our observed results with expected results and decide whether what we have is significant or non-significant at all, and whether a given factor is really important in bringing about changes. So the first stage in carrying out this test is to work out the expected value. We need to know how to work out the expected value. Like people who carry out genetics, there's expected ratios. For people who work on, let's say, growth of bacteria, the expected number of colonies that are expected to grow. There are things that one always expects, but again what you observe in an experiment may be different. So we must be able to calculate the expected results. We must have expected results on one column, and then we write also our observed results. Then we can manipulate everything that we have, just like I've showed you in the formula. When you try to look at the formula, you'll see that we have to know the E, the O, we must know everything. So we must be in position to manipulate whatever we have. So if we get a chi-squared value, then we immediately run to the probability table that is always given, or that was already prepared to look at the probabilities, to get to know whether what the chi-squared value we are having shows results that are occurring just by chance or it is a significant difference. So for us as biologists, we normally consider a probability of 0.05. What does this mean? This means that we expect maybe 5 out of every 100. That's what we normally consider. However, there are other probabilities of like 0.01, that is 1 out of 100, because there's something occurring by chance. But for us, our limit or our probability we use as scientists in biology, we use the probability of 0.05, and I'll show you how it works out. Don't get scared, don't cry. I'm going to show you how it works out. So the probabilities within the 0.05 normally give us the critical values of the chi-squared, which we can use to interpret our results. And we say that in the biological experiments, we usually take a probability of 0.05 as being the critical one. So if our chi-squared value represents a probability of 0.05 or larger, then we can fairly certain that the difference between our observed and expected results are due to chance. I'm going to show you this, don't worry. And the difference between them are not significant. However, if the probability is smaller than 0.05, if it is smaller than 0.05, then it is likely that the difference is significant. Definitely, if we get something that is smaller than 0.05, let's say, okay, I'll show you in the example that we are going to do. So we cannot just take it lightly. So We have another aspect that we must know is the degree of freedom in our results. The degree of freedom is very important in establishing the chi-squared value that we are going to analyze. I'll give you a simple illustration of the degree of freedom so that you can get to know as we work out our work. Let's say that we have let's say we have 5 chairs. Let me do this. Let's say we have 5 chairs, 5 chairs that are going to be sat on by 5 different people. So let's say that those are 4. This is 5. These are 5 chairs, and we have 5 people. We have, let me use this color. Let's say we have 5 people. This is 1, 2, 3, 4, 5. So we want to establish what is the degree of freedom of these 5 people with the 5 chairs. So let's work it out together. So this individual has the chance to sit on any chair he feels like. So there are 5 chairs, there are 5 people, and I want to establish the degree of freedom at the end of it all. So this one has 5 chances. You can sit on any chair. So let's say that this one has sat on this first chair. So how many chairs have remained? Only 4, with 4 people. So that is 1 now. He had an opportunity of to choose, let's say, from 5, but now the number has reduced. The degree of freedom has, the freedom has reduced. So this second person has the chances of sitting on either this, or this. However, let's say that he has sat on this. So the degree of freedom is reducing. So we now have 3. So this individual 3 has a chance can sit on any of these 3. So let's say he has chosen to sit on this. So the degree of freedom now is reducing. And then we have the 4th person has a chance either to sit on this or to sit on this. So this individual, let's say, has sat on this. So that means he had a chance to choose from. However, the 5th person has no chance of choosing which chair to sit on, but rather he just has to sit on this. That means there's no freedom at all. So in this case, if we have 5 classes, the degree of freedom will be 4. That's why we're saying that the degree of freedom is always less by 1. It is always less by 1. That's how we need to know. So if we're dealing with a class or a class of 4, that means the degree of freedom is 3, and that is very important when we are using the chi-squared value, or when we are trying to establish the significance of a given chi-squared value that has been obtained. So you must know the classes, how many classes you have, so that you can establish the degree of freedom. But the hint is always subtract the number of classes by 1 and you get to know the degree of freedom. Let's look at this table, and we need to understand it clearly so that we can use it in analysis of data. So if we have the chi-squared values provided in the table, our focus as biologists, we should focus on the probability of 0.05. That's the probability that we focus on as biologists. Then also the values that we have here are the chi-squared values. These values here are the chi-squared values. So in case, or what do these chi-squared values under this probability show? They show that the difference between the expected and the observed are due to chance. Let's talk briefly about the degree of freedom, and then later on we can use this table to analyze or to calculate our values and to know whether there's the observed and expected, there's a significant difference. So when you have a degree of freedom of 1, it implies that the individual or the experimenter was having 2 classes. If you have a degree of freedom of 2, that means you had 3 classes. If you have a degree of freedom of 3, that means you had 4 classes. If you have a degree of freedom of 4, that means you had 5 classes. So what do these values really mean? Let's say we have a degree of freedom, let's say of 3. We'll expect that the expected chi-squared value would be 7.82. However, during the manipulation, you may get a value that is, let's say, smaller than the 7.82. That means the value, let's say you have got a chi-squared value of, let's say you have got 0 point, let's say 92. Let's say that is the chi-squared value that you calculated. It means that that value you have got is far much smaller than the 7.8. That means if we were to trace it under the degree of freedom of 3, we'd find that that value is on the extreme left, meaning that its probability would be close to 0. Let's say 0.1. That is roughly 1 out of 10, meaning that things are just occurring by chance. Everything you're getting is almost occurring just by chance. That's the implication, meaning that the difference, or the observed difference, is not really significant at all. In case you get a value that is far smaller than the chi-squared value that tallies with the 0.05, that is the implication, and we're going to see that in our calculation. We have a simple question here. We're given a table, and we're given also the formula that is of the chi-squared test, and we're told to fill up the table and to get the results. So whenever you're given results, or whenever you have carried out an experiment, it is important to draw a table with headings and with also these this data or these headings that reflect what is in the formula, so that you can easily calculate the chi-squared value with ease. Make sure you are very smart. So these are our results, and we can complete this table with ease and then also calculate the chi-squared value. So I've completed my table. I guess you can also complete your table as fast as possible. That's how it looks like, and I guess we have similar results. Now let's go into the interpretation of our results. So the chi-squared value that we have got is 2.78, basing on our table of degree of freedom. So the degree of freedom was 3 and it was extracted, and our attention should be focused on the value that is tallies with the 0.05 probability. So this is our probability of 0.05, and then the chi-squared value that we have is 7.82. That's what we have, and our chi-squared value is 2.78. I guess you can see it. So what does this tell us, or what does this show to us? It shows us that the value we have got is far much less than 7.8. In other words, it is on, if we were to trace it in this row, it would be on the extreme left. Okay, I think it is between 0.05 and 0.2. It is in between there. This means that the value we have got is of a probability that is actually, when you look at this, the probability is far much greater than 0.05. It is in between 0.05 and 0.2. The probability is far much greater. That means let's say it is between maybe it is close to 0.5. that is roughly 5 out of every 10. This is a very big value if things are just occurring by chance. So this means that the value we have got is far much less than the chi-squared value that corresponds to the probability of 0.05. That means the difference between the expected and the observed are just occurring by chance, and this value is really very big. So in this case, we say that the observed difference between the expected and observed is really non-significant. the results that we have are just due to chance. So we can make a simple conclusion in that form. So I guess you enjoyed these calculations and also the interpretations. Don't forget that I'm Enoch. I'm an IB consultant in the specifically biology and chemistry. And then also I'm a Cambridge teacher trainer. I do facilitate modules concerning Cambridge, especially in digital technologies. And then also you can reach me on my WhatsApp. My WhatsApp is just given here. You can reach me as fast as possible. It's always on day and night. Then also you can visit my website, know more about me, and then also the things that I do and the services I do offer. And then also you can send me an email, and then in case it's something different from this, I build websites. You can contact me and I build you a wonderful website for your business, for your project, at a very cheap or at a very low cost. Thank you for watching Enoch's videos. Don't forget to subscribe, tell a friend to tell a friend and tell a friend. Thank you. Bye bye.